New overflow 2. Okay, let's try manipulating arguments. You can find it here. Arguments aren't stored on the stack anymore. That's true. So the first argument on a 64-bit is in RDI and RSI. Let's see what we have here. All right, we have our normal set group ID executable. Here's our vuln.c. Simple classic buffer overflow. We're going to get a string from the keyboard. Looks like they've left in the same flag method, so I don't see what they're talking about with parameters. Oh, I see. I think this was an accident. They probably meant to take out this flag method. So they probably wanted me to call win function 1 and pass it dead beef, and call win function 2 and pass it bad cafe, cafe beb, cafe babby, babe, and a bad babe, and then call the win function. The win function will only print the flag if win1 and win2 have both been called. All right, the problem with that is I think this program is a little too small for me to really do return-oriented programming, which I would need in order to get values popped out of the stack and into registers. So what you would do in return-oriented programming is you would look for like pop RDI return, and then you would try to find that sequence somewhere. So it's probably going to be really hard for me to actually do this the way they intended. But let's go ahead and take a look at the assembly. All right, so there's win function 1. You'll see that its parameter was in RDI, and then they compare that to dead beef. And win function 2, you have RDI, RSI, and RDX. So if we were to look for like pop RDI ret, so there's a nice article on what is ROP. Right, so we would want to use something like ROP gadget to find these things. And we're probably not going to be able to find them in such a small program. We could find them in libc. Libc is going to be randomly moving around each time the program gets loaded, so that's probably not going to be helpful. But what I think I can do instead, which will be at least a little bit more interesting than just calling flag directly like we've done before, is jump into the middle of the method, right? So that sort of highlights the idea of ROP, is instead of going directly to win function 2, I'll jump right here to this move B. So we'll look for 4007B4 for win function 2. And here we'll jump into the middle of win function 1 at 400777. And then we'll go to win function. So 400777, 4007B4, and then 7BE. All right, so Python, let's see, print. And I think we had 64 A's in our buffer. I think it was at IJKL is where we found from the previous problem that our addresses should be. So let's go with 777. And then we need 5. And then we have 7B4. 2, 3, 4, 5, and then 7BE. 1, 2, 3, 4, 5. that in a file. We'll run that. We got nope, not quite. Let's see what nope, not quite was. Oh, we didn't actually get. So we made it into win function, but we didn't have both win1 and win2 set. So let's see what happened to me there. Let's go into GDB. Actually, that's not, I'm not going to really stop at either win function 1 or win function 2, but let's do a break in Vuln, and then we'll run. All right, so here we are in Vuln, and there's the return at 40008 CD. Insert breakpoint 5. Oh, it's 4008 CD. Okay, delete 5. Okay, here we are, x4x $RSP. So we're going to go to 400777. That looks perfect. So let's see what happens there. Right, that looks good. And then oh, we went directly from here to 4007B4. Okay, so let's look at the end of so there was a pop here, right? So we didn't think about this pop when I was building my string. So I had a pop. 1, 2, 3, 4, 5, 6, 7, 8. There's probably a pop at the end of this one as well. 1, 2, 3, 4, 5, 6, 7, 8. Let's actually go ahead and verify that. What's at the end of win function 2? So at the end of win function 2, we have, yeah, that one pop again. So all right, so now we got a segmentation fault. So let's see what's going on with that. You know, I bet I know what's going on with that, because we had this problem before, right? We had this problem with the move APS instruction. So what I think I'm going to do is I'm just going to add that 4007BD an extra time. If I add that so that's just going to add one additional return there. And that should hopefully align my stack on an 8-byte boundary. Because you remember from the previous one, we had that move APS command, and I needed my stack to be on a 16-byte boundary in order to do the printf for the flag. So maybe that'll just solve my problem. There it is, ROP it, don't stop it. We'll throw that in over here and grab some points.